Imagine trying to solve a puzzle when you aren't allowed to see the picture on the box. That is how abstract math often feels for our students. It's why I'm so excited to share how concrete representational abstract framework can help them literally see and feel math they are learning. For those of you who don't know me, I'm Jamise Posey. As a second year special education teacher who hadn't personally taken or taught formal math in decades, I wanted to make sure I was presenting math to my students in the most accessible way possible. I don't want to just show my students how to memorize steps. By mastering the CRA framework, I wanted to change how I react when a student gets stuck, giving me the tools to pivot backward to a drawing or a physical tool so we can break through that barrier together. And that brings us to the core of my Knowledge is Golden project. Today, I want to share how we can intentionally design math lessons that bridge the gap between math lessons, hands on tools, and traditional numbers using CRA to build deep, lasting conceptual understanding in special education. As a second year special education teacher, passionate about helping students see and feel math rather than struggle through a blind puzzle of abstract rules, I am excited to show you how the concrete representational abstract CRA framework builds a predictable, hands on pathway to success. Imagine trying to solve a puzzle when you aren't allowed to see the picture on the box. That is how abstract. Why CRA? Many special education students, as well as general students, struggle with working memory and abstract mathematical reasoning. Jumping straight to formulas and rules can cause math anxiety and learn helplessness. Our goal is to shift from showing how to do math to helping students see and feel math. What is the CRA framework? Concrete, physical interaction with 3D objects. Representational, visual, semi concrete, designs, drawings, and diagrams. Abstract, traditional mathematical symbols and numbers. Concrete, the physical. Students physically manipulate 3D objects to solve problems, builds muscle memory and spatial awareness of mathematical amounts. Examples using base 10 blocks, fraction tiles, algebra tiles, or counters. Representational, the pictorial. Students replace physical objects with visible drawings. Acts as a crucial mental bridge from physical world to abstract ideas. Examples: drawing dots, tally marks, bar models, or using virtual manipulatives on Chromebooks. Abstract, the math. Key points: students translate drawings into standard numerical symbols and mathematical operations, addition, subtraction, multiplication, division. Concepts are now anchored in physical and visual mental schematics. Putting CRA into action. Strategic lesson design. How to plan units that explicitly budget time for all three phases. The pivot strategy. When a student gets stuck on an abstract calculation, Pivot backward to a representational drawing or concrete object to break down the barrier. Hello, I'm Miss Posey to my students, and I am Mommy to you. Today, Essence, I am going to be interviewing you. As you know, I'm in school and I'm taking a math class where I can teach other students. And I want to thank you for allowing me to interview you today. Do you give me consent to film you and video you?
Yes.
Okay, perfect. So we're going to work on hands-on equation. We have a scale. This is our balancing scale. And I have some manipulatives here. These are our pawns, they're blue, and our dice. These will represent the numbers. This will represent the X. So we're doing hands-on equations. So the object is to balance it out. We're going to have pawns and numbers. Okay. What you do to one side, you can do to the other side. So if I take away 2 from here, I can take away 2 from here if it allows me. So I'll give you an example. Let's say 3x equals, this is our equal, 4 plus, or I will say 2 plus 4. So what I want to do is take away all the blues and try to just have the green, okay? So I'll remove 2 here and 2 here. That leaves me with 1 pawn, which is my X, and 4, which means X equals 4. This is my X, and this is 4, okay? I'll put everything back. So now I'm counting the pawns by 4s. And we're going to see if the numbers are the same on each side. So if this is 3 4s, I have 4, 8, and 12. 4, 8 plus 4 is 12. 12 and 12. Do you understand how that goes? Okay. So I have you a worksheet with several equations. You can go down the worksheet and work it out. Let us know what X equals and how do you check your work. The first one, 2x equals x plus 3.
Okay. So I did 2x plus x equals 3. So since we're trying to equal it out, we're going to take 1. We're going to take 1. And now that gives me x is 3. So I'll put that and I'll put x is 3. And I'll put it back. So now these x's are equaling 3. So 1, 2, 3, 4, 5, 6. That's 6. And then 3, 4, 5, 6. So that's 6. And then since that's 6, I'll put 6 on the paper.
Okay. How about number 2?
Okay. It says 3x. So I'll put 3x on this one. Plus x equals 4. So 4. Okay.
Now I have a question.
Mm-hmm.
This middle side is equal. Okay.
Yep.
And the left side is x equals 4 or x plus 4?
Plus.
Oh, okay.
Okay. And since I only have 1 right here, I'll take 1, and I'll take 1 from right here. And for 2 numbers that can equal 4 and make 4 is 2. So this can go by 2. Okay, so I'll put this back. Now x will go by 2. So 1, 2, 3, 4, 5, 6. That's 6. Now this is 4. So 4, 5, 6. That's 6. And x is going by 2. So I'll put 2. And then it's also going by, the equation is 6. And it equals 6. Okay. And the next one is x. So x plus 4. So we'll get a number. We'll put it right there. And then equals 2x. So get 2 of these. Plus 3. So 3. Okay. Now I have 2 x's right here. And I have 1 x. So I'll be taking 1 x and 1 x. Okay. Now I can subtract. Okay. So I can take this away. And I can do this. So this will be 1. So x will be going by 1. Put it back to 3. This will be 4. And then this will be that. Okay, so now these will be going by 1. So I put that on my paper. And this will be going by 1. So 4 plus 1 is 5. And 3 plus 2 is 5. So they're equaling up the same. So put that right there. So this is 5.
Okay. I have a quick question. The 4 and the 3, you turned the 3 into 1. Can you explain why you did that?
Because it won't be equaling up. One side would be up and one side would be down. And we're trying to measure it up. So I just subtract.
Oh, you subtracted the 3 from 4, and that's why you turned it to 1. Okay, got it.
Okay. The last one. It says 4x, so we'll get 4 of these. 4x plus 2x, so 2. And then it says plus 6. So find me a 6. Okay, so we're trying to equal it out. So I'll take 2 away and 2 away. 3. This would go by 3 because 3 and 3 is 6. So the x will be going by 3. Okay, I'll put this 2 back and I'll put these 2 back. Now these will be going by 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this side is 12. Let's see about this side. This is 6. 6 plus 2 is 12. So both of these are going by 12.
6 plus 2 is 12?
Yeah.
Okay.
And so now, since we were going by 2, the x would be 2, and the answer would be 12.
Okay. Can you explain it to me one more time? I think I'm a little lost.
Okay. 4x equals 2x plus 6. Take away these 2. Take away these 2. 3 and 3 equals 6. So these will be going by 6. By 3. My bad.
Okay.
I messed up on that.
That's okay. Because I'm learning, so you're teaching me.
So it would be going by 3.
Okay.
Oops, I put 2. So it'll be going by 3. Okay, so put these back. And then these will be going by 3, so now we're going to count by 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay, so 6, 7, 8, 9, 10, 11, 12. 12.
Okay.
12 on both sides. So the x is going by 3. So x is 3, and the answer is 12.
Oh, man. Okay, I get it. So I was starting off with my x's and my dice, which are numbers. So I worked out the equation hands-on. Thank you. Learned something new today on how to break down the equations and make everything balanced. Thank you for helping me with my assignment.
You're welcome.
So I'll collect your work. Can you put your name and today's date?
Today's date is 4. I mean, whoa, not 4, it's 5.
Mm-hmm.
1/26.
Wonderful. Now, you may want to know, how does this help my students? It moves them beyond rote memorization by building visual and hands-on pathways to complex sixth grade math concepts, boosting retention, building confidence, and lowering math anxiety. How it helps me as a teacher: it takes the guesswork out of progress monitoring. You can instantly see where a conceptual gap occurs, track IEP goals with concrete data, and differentiate instruction without redesigning your whole lesson. Now, for my overall classroom environment, it lowers cognitive load and frustration, which drastically cuts down task avoidant behaviors. It transforms the classroom into an interactive, collaborative space where all learners can access grade level standards at their own pace. CRA bridges the gap between hands on learning and abstract middle school math. It empowers students with deeper understanding, gives teachers real time diagnostic clarity, and creates an engaging, low anxiety classroom where all students can succeed.